Hall thruster. Principle and advantages of Hall thruster. Traditional fossil fuel is not only the first choice for aviation fuel because its weight is too large to increase the load of spacecraft, but also its combustion efficiency is particularly low. Therefore, scientists have been looking for alternatives. In this way, Hall thruster appears, and its electric propulsion mode will lead people to another Zintiandi. According to the data, the fuel carried by liquid and solid rocket engines now accounts for more than 60% of the total weight, while the payload, instruments, equipment or subsystems directly performing specific space missions, accounts for less than 10%. Unlike traditional propulsion, Hall electric thruster works by converting electric energy into kinetic energy. The thruster operates based on the Hall effect principle, and its discharge channel has a strong magnetic field inside. Hall effect will cause a large number of electrons to be captured by the magnetic field and do high-speed gyration and drift motion, and the propellant gas molecules released from the thruster will meet and collide with these electrons when passing through the discharge channel. After the collision, the xenon atoms will become xenon ions, which are ejected at high speed under the action of the electrostatic field in the discharge channel, thus generating a certain thrust. From the perspective of the structure of the Hall thruster alone, it is not very complicated. It is composed of hollow cathode, anode, magnetic pole, propellant, etc. So what are the advantages of Hall thrusters? First of all, compared with chemical propulsion, the average speed of working medium in electric propulsion will be faster. For example, the 300 V voltage can accelerate the ion to 15 to 20 km per second, and the current limit speed of ion injection is about 60 to 80 km per second. Secondly, the specific impulse of the Hall thruster is higher. The specific impulse actually refers to the impulse generated by the unit mass of propellant. It is no surprise that the higher the specific impulse means the higher the propulsion efficiency. In this case, the specific impulse of Hall thruster is about 10 times that of fossil fuel propulsion. Finally, because of the higher specific impulse, Hall thruster can successfully complete the task with less propellant. Remember what we said above, half of today's space vehicles are loaded with fuel, which does not exist in Hall thrusters. The research shows that a geostationary satellite of about 5 tons can significantly reduce the mass of propellant carried by the satellite from 300 kg to 500 kilograms, and the mass of the satellite can be reduced to half of the original one, which can significantly reduce the difficulty and cost of satellite construction. To sum up, compared with the traditional propulsion method, Hall thruster does have the advantages of rolling, so why would someone say that it can only push a piece of paper? In fact, the statement that Hall thruster can only push a piece of paper is not exaggerated, because the thrust it produces is really small. For example, the X3 Hall thruster, which was tested in the United States in 2018, has become the largest thrust in the world, but the thrust has only reached 5.4 N. Therefore, the thrust of most Hall thrusters is still hovering around 1 N, and some are even lower. In this case, only one piece of paper or several pieces of paper can be pushed. But we have neglected that there is a huge difference between the cosmic environment and our environment. Because the environment in space is almost vacuum, there is no air and other interference factors, which makes the impact of friction very small. In this case, the Hall thruster, which can only push one piece of paper at a time, can also keep the aircraft in a relatively stable state with the accumulated thrust. It can be seen that in this case, the Hall thruster with small thrust can still meet the on-orbit requirements of the Tiangong space station. In addition, compared with the promotion of traditional fuels, it can be said to be quite economical. In order to maintain the same height, the fuel consumption of the International Space Station is up to 4 tons per year. If Hall electric propulsion is used, the propellant consumption is about 800 kilograms to achieve the same orbital lifting effect. It can be seen that electric propulsion can bring greater economic benefits. Future application and development trend of Hall thruster. Hall thruster has been the focus of research in various countries since its appearance. Under continuous research, its power has changed and its thrust has also improved significantly. It can be said that with the continuous development of the Hall thruster, its role in the future will not be limited to maintaining the orbital height of the space station or satellite, and can even become the preferred propulsion device for human long-distance space exploration. Hall thruster has the following development trends in the future. The first is that its performance needs to be improved. Whether it is efficiency, specific impulse, or starting speed, it needs to be further upgraded. The second is to extend their working life. Once it is further developed and has greater impetus, it will have the opportunity to take humans to further places.